Okay, so the next one says, which two characteristics do all Jovian planets have in common? Well, you have to know that the Jovian planets, J for Jovian, J for Jupiter. So you're going to talk about from Jupiter on. Okay, so you're going to look at reference table page 15, right? And it's going to be Jupiter, Saturn, Uranus, Neptune. Not the Earth's moon, just in case you don't know that. Okay, so let's look. They're talking about their diameters, so equatorial diameter. They are much larger than the terrestrial planets, right? And they have lower densities than the terrestrial planets. So that's straight off the reference table. 42, because Venus has a greater atmospheric carbon dioxide, which we know is one of those greenhouse gases, right? Which is going to create that nice warm blanket on top and hold all of the heat inside, okay? So it's going to be warmer. That's number one. Now, why is it warmer? Because of the absorption of long wave infrared, right? Infrared comes back out, right? You guys remember this? UV comes in, infrared comes out.
You should not get a Venus question wrong. For Pete's sake, we spent so much time on it. Okay, here we go. The object in a photograph is most likely not a potato. It looks like one. It's a space potato. What do we call a space potato made out of rock? An asteroid. Seriously, do not get this one wrong.
It's Mercury. I think the answer is Mercury.
44. Scientists infer that the Earth's earliest atmosphere was produced by. We talked about this. Earth, when it first formed, had no atmosphere. It got an atmosphere. Why? Because it had a whole bunch of volcanoes. Those volcanoes went off and spit out all the stuff that was on the inside, and it formed the envelope around the Earth, which we today call an atmosphere. Ooh.
Okay, the constellation Orion is visible at night in New York State when Earth is at position A, but not at position C. Well, why is that? Like right now, if you go outside at night, you can see Orion, right? It happens because as we go around the sun, we have those constellations that are called seasonal constellations, right? They are seasonal constellations because you can only see them during certain seasons because we are revolving around the sun. Okay, so, and you have to remember, if we're facing the sun, you cannot see the stars. Like right now, during the day, you cannot see the stars. But if you use your app, they are still there. Okay, so it's the nighttime side is facing toward a different portion of space. 46, you should all get this right, okay? Big Bang occurred approximately between 12 and 15 billion years ago. They like to put 13.8 on there all the time, but remember it's between 12 and 15 billion years ago. 7 and 9 billion we never talked about. 4.6 billion is...
Creation of the Earth, solar system, everybody that's floating around us right now.
Okay, go.
47. According to the Big Bang Theory, which graph represents the relationship between time and size of the universe? So basically what happened? As time went on, the universe got bigger and bigger. Remember, we talked about this as inflation.
Red spread.
Right? The universe has gotten bigger and bigger the older it gets, much like all of us. The older we get, we tend to get a little bit bigger. Not vertically, but horizontally.
Okay, this one you guys have seen before, but if you look at the graph, it says that years of having the greatest number of sunspots occur. Well, it's not going to be random because look at the number of sunspots. They peak at specific times, and it looks like every year, every 2 years, or however many, 10 years, right, they peak at the exact same time, okay? So this is a cyclic pattern approximately every 11 years, and you have to look at the graph for that and figure out how many years is each one of the lines worth, right? And since there's only 4 in between 1850 and 1860, that tells me that that line is worth 2. So it's approximately 11 years.
Or you could remember in my class, that's exactly what we said. Sunspots happen in an 11-year pattern. I gave you this information.
Just in case they forget. Okay, so compared to the temperature and luminosity from one star to another. So specifically Polaris and the star Sirius. So Polaris is 0. This is Sirius, and Polaris is right above it here, right? So luminosity. Polaris is going to be more luminous and cooler compared to Sirius, which means that Sirius is going to be less luminous, but it's hotter. Remember, this line goes backwards than what we're used to. You guys are used to this being at 0 and this being at a higher number. Do not get these questions wrong because this is Earth Science Reference Table, page 15. Make sure you look at the axes before you do anything else. Question 50. Which process represented in the model is occurring in each layer of this star to produce the new chemical elements? Well, in order for this to happen, right, you're basically having, it says it in here, in each layer, atomic nuclei of existing chemical element combine to form new elements shown in general. So if you have the nuclei, you know it's going to be nuclear, right? And if they're combining to form new elements, it means that they're fusing together. So that's going to be nuclear fusion. You guys have not heard of contact metamorphism yet. You have not heard of internal crystallization yet. And you really have not heard of radioactive decay yet. So the only answer that makes sense is nuclear fusion.
And guys, come on, let's be honest. Whenever we talk about stars, we said stars create new things because of nuclear fusion.